Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Fatma Liagou. Today I'll present a presentation of electric energy project talking about single phase power system. We are Fatima Liagou and Gharam Al-Unizi from University of Hafr al-Batin, Department of Electrical Engineering, instructor Dr. Naif Najjar. First, the requirements of the project. Here in this project, we have to deal with a single phase power system consists of a 415 volt 16 Hz generator supplying a load pan consists of 3 load through transmission line of impedances ZL equals 0.xx plus J 0.yy. Second, we have to use our IDs to solve XX equal first two digits of our student IDs, YY equals last two digits of our student IDs. Third, design T1 and T2 by giving appropriate number of turns N1, N2, M1, and M2. Fourth, determine where should be the tap position in M2, what will be the value of M2 for each tapping position APC. Fifth, specifically investigate when K2 is connected with any of the load, what the tap position K1 will select and why. Sixth, if there was no transformer in the system, in the figure we have below, how much power L1 will draw from the system. Introduction. Power and phases. In electricity we have many types of phases, and the phase refers to the distribution of a load. We look into them by either when the voltage is out of phase from each other and two when the voltage is out of phase from the current. And here we're going to talk about single phase power system, where you only have one wire with a varying voltage and a ground wire. And about the definition of single phase power system, it's a two-wire alternating current AC power circuit. Typically there is one power wire, the phase wire, and one neutral wire with current flowing between the power wire through the load and the neutral wire. If we want to solve the project problem, first thing we have to know is that the solution of the project includes two IDs, but we will discuss only one solution because we got the same final result. And also due to time constraints, we will not be able to discuss the two solutions together. So, first step is that we have to put our assumption as shown here. T1 is turn ratio and T2 is also turn ratio. A is N1 over N2 and A2 is M1 over M2. P line equal P losses equal 10% of P load, which means that it's 0.1 of P load. Z line, as I mentioned before, XX is the two first digits of our IDs and YY is the last two digits of our IDs. So X will be 22 and Y will be 0.2. Equation circuit refer to line part. Here we have AC voltage source Vs over A1, and here R is equal to 0.22 plus L will be equal to 0.02. And here we have the Z load. Here part 1, light load 1 is connected. We have the circuit as shown here. And also they provided us with the value of V load and P line. P load which is equal to 200 watts and P line which is equal to 20 watts. Now we want to get the value of IL. How? By using this equation. PL1 is equal to IL square multiplied with RL1. Now we're gonna substitute PL is equal to 200 and RL is equal to 4. How can we get the value of I? By taking the absolute value of 200 over 4 and we get the value which is equal to 7.07 ampere. Now we want to get the value of IL dash. How? By using this equation. P line is equal to I line dash square multiplied with R line. Now we're gonna substitute also 20 is equal to IL dash square multiplied with 0.22. And also we're gonna take the absolute value of 20 over 0.22 and we got the value which is equal to 9.53 ampere. Now we want to get the value of A2 by using this. IL dash over IL equals to M2 over M1, which is equal to 9.53 over 7.07, which is equal to approximately 1.35. We know that A2 is equal to m1 over m2, and if we assume that m1 is equal to 1, we will get that A2 is equal to 0.741. And now to find A1, which is equal to n1 over n2, we're going to use this equivalent circuit, and we're going to substitute I is equal to V over Z. So V, which is equal to Vs over A1, and Z. Now we're going to substitute Vs, which is equal to 450 over A, the value we want to get, and over the absolute value of Z line plus Z load, the values of R plus the values of L. Now we're gonna substitute by using calculator, and we got the value. Now we're gonna find L1 without any transformer. So we're gonna use this equivalent circuit, and I is equal to Vs over Z line plus Z load. So we're gonna substitute Vs, which is equal to 415 over the absolute value of R plus L. Now we're gonna get the value by using the calculator. So P line is equal to P losses equals to I square multiplied with R, which is equal to 0.22. We're gonna use the calculator to get the values, which is equal to 1654.5 watt. Now, if we want to get the P losses with a transformer, we're gonna use this equation: P losses without any transformer over P losses with a transformer. Now we're gonna substitute P losses without any transformer we got here, which is equal to 1654.5 over 20, which is equal to approximately 83. Now losses with a transformer is approximately equals to 83 times the P losses of transformer.
Assalamu alaikum warahmatullahi wabarakatuh. Good evening everyone. I hope you are all doing well. Let me start by introducing myself. My name is Gharam Al-Anizi. I will continue to explain what my friend Fatma stopped at, and I am going to talk for about 5 minutes. Here in part 2, assume medium load L2 is connected. We solving like part 1, but with a new value. Z load 2 equal 3 plus J4, and B load 2 equal 800 watt meter, and B line equal 80 watt meter. The first we calculation B load 2 to find I2, and then we calculation B line to find I2 dash. The first B load 2 we use Ohm law to find I2. I multiply R, which is I2 square, multiply RL2. We substitute here B load 2 to 800 and RL2 to 3. So this from this equation we use the square root to cancel the square. So I2 equal square root 800 over 3, which is equal 16.33 ampere. And B line the same, we use the Ohm law to find I2 dash. So the equation Li2 square dash multiply R, which is 0.22, and then we use the square root 80 over 0.22 equal 19.1 almost ampere. Here from the law of proportionality we find that I2 dash over I2 equal M2 over M1. So the last value M2 over M1 equal 1.2. If M1 equal 1 and M2 equal 1.2, we take inverse M2 over M1 to get A2, which is A2 equal M1 over M2 equal 0.83. To find A1, must find N1 over N2. From this equation, A2 dash equal Vs over V1 over Z line plus ZL dash. Okay, A2 dash equal 19.1 and Vs equal 415 over A1, which is the A1, it's not found yet. So Here to solve this equation we used cross multiply to find A1. So A1 equal 68.57 over 415 over A1, and A1 equal 415 over 68.57, which is N1 over N2 equal 6.6 almost. Here in part 3, this circuit was solved with the same steps as the previous one with a different value. I told you quickly because we have the short time. The first step, Z3 equal 4 plus J2 and B load 2 equal 1200 watt meter and B line equal 120 watt meter. B load and B line we use Ohm law to find I3 and I3 dash, and from law of proportion we find M2 over M1. We take the inverse to get A2. To find A2 we use the same equation, A3 dash Vs over A1 over Z line plus ZL dash. We cross multiply to find A1, which is equal 7.23. The summary of our result for load 1, T1 equals 16.06 and T2 equal 1.35. For load 2, T1 equals 6.6 and T2 equal 1.2. For load 3, T1 equal 7.23 and T2 equal 1.35. We conclusion in load 1 and load 3, T2 it's the same. So we conclusion here from the result, and by comparing M2 over M1 we can find that L1 and L3 is stable for position A and L2 is stable for position B. Here when we look to the circuit diagram we conclusion that. The last thing, this reference and research we used in our presentation.